Hey, what's going on, everybody? It's a beautiful day for math. Let's get after it. Similar polygons. Make sure you have your textbook open to 546 and take great notes. This chapter, our notes are all going to be in our textbook. So get it out and make sure you're copying things down that you think will help you prepare for any of our tests or quizzes and prepare you to really understand these lessons. We're talking about similar polygons today. That's a little different than congruent polygons. Congruent are perfectly the same, whereas similar polygons, they have some parts the same, but some parts are going to be different. Basically, similar polygons are polygons that are the same shape, but different size. They're just expanded, grown, or shrunken. So let's look at some of the specifics about similar polygons. In words, if two polygons are similar, they share these two important features. Number one, their corresponding angles are congruent. And number two, the measures of their corresponding sides are proportional. What does that mean? That means they make equal ratios or fractions. So if you pair up the side lengths, the corresponding side lengths, you pair them up, one from one shape, one from the corresponding part of the other shape, all the pairs will form equal fractions. You can see that right down here. Now that might not make sense to you, but AB over XY, see where that fraction is? That's the length of AB. That's the length of one side, the length of AB right there, and the length of XY. So when you find those lengths and divide them in that fraction, you should get the same exact result as if you took BC and divided that length by YZ, that length. And also for the last pair of corresponding sides. So we know some of this. We've practiced a little bit of it as we've talked about dilations. So it shouldn't be completely new to you. The first thing right here that we talked about, that the corresponding angles are congruent, that's sometimes hard to realize, but you see that, all right, there's two arcs here and two arcs there, meaning those two are congruent. They're the same. So the measures of the angles don't expand at all when you grow the shape, or shrink when you shrink the shape. The angles stay the same while the side lengths change. They change in a special way. They change proportionally. All right, I did copy and paste this to another screen so I could prove that the angles stay the same. If I were to outline this shape, here, all right, and that's B right there. So if I take angle B and drag it over here, it's the same exact angle as angle Y. Now check out angle C over here. Find angle C. See that bottom right corner there? If I take it over here and put it on top of Z, it fits perfectly. If I look at angle A, everybody check out angle A, and I slide it over, it fits perfectly on top of angle X. Okay, so those corresponding angles remain congruent while the side lengths change. Let's get back to the lesson, and let's use this information to help us solve some problems. All right, polygons that have the same shape are called similar polygons. I'm also going to add a little piece to this. They have the same shape, but they also have the same, they have different size. They either grew or shrunk. Now, we know that the parts of similar figures that match are called corresponding parts. I'm going to be using that phrase a bunch as we discuss this lesson. Now, moving on to example 1. You're going to have to have two skills coming out of this lesson. One is just tell if two shapes are similar or not. All right, you can run 2 tests and see if it's similar. So that's what we're going to start with. We're going to determine whether they're similar. Is it similar? Are these shapes similar? The second skill that you're going to have is that they're going to tell you, they're going to show you 2 shapes, and they're going to tell you they are similar, and then you're going to have to figure out some missing lengths of sides. So that's what we're going to do second. Right now, we're just determining if these are similar. So we know our 2 rules. To be similar, they have to have all the corresponding angles are congruent, and that the corresponding sides are proportional. So let's run 2 tests to see if those 2 things are true about these 2 shapes. All right. You can see this is an example. They've already done the work for you. It says first check to see if corresponding angles are congruent. Since the 2 polygons are rectangles, well, they're all going to be right angles. So the corresponding angles are congruent. So we checked off that first piece. The corresponding angles are congruent, but now we have to do that second part where we check to see if the fractions we make out of corresponding side lengths are also going to be equal. So let's see. Now down here, this is kind of confusing. All right, but hopefully we'll clear it up in a sec. So I'm just going to use different colors to highlight these, and hopefully it helps you see what we're doing. We just make pairs. We make pairs, turn them into fractions, and see what happens. So what did they do? They took the sides of the lengths of the corresponding sides. So HJ is right here. What's its length? 7. So that went right here. And the corresponding side to HJ? Well, that would be MN. And what's its length? 10, which goes down here. So you made a ratio of corresponding lengths. Now we'll go over to the next length, JK and NP, corresponding lengths again. And we make a fraction there, 3 and 6. We make the fraction of the corresponding lengths. Now, I would have stopped there because I already see that these 2 are not equal. 1/2 and 7/10, obviously not equal. So therefore, if the ratios aren't equal, they're not proportional. Proportional means equal ratios or equal fractions. So this already, we've proven it. But now they've gone ahead and done it, checked all of them out here. They've checked all of them. We have KL, right? We have KL and PQ. We check that fraction. And the final one, they have HL and MQ, or vice versa. And since there's different ratios here, they don't all equal the same thing. They are not similar. Why? Because they are not equivalent ratios. So now you try it on your own. Go ahead and pause. Test the ratios of corresponding side lengths to see if these are similar shapes. Determine, this is this type of problem, if they're similar. Determine if they're similar. Well, we kind of, with the angles, we kind of can eyeball and say, it looks like they're the same. So what should we do? We should test the ratios of the side lengths. So we're going to test out if AC, and what does AC correspond with? AC corresponds with XZ. We're going to see if that ratio, 6 to 8, if that is equal to the ratios of the other side lengths. So let's go AB, and AB would correspond with XY. Now we could see that visually pretty easily. 8 and 12. And then we also have that final side length pair, which would be BC and YZ. We put that's the same ratio as the first one. So at least they're equal, but are all 3 equal? All of them have to be equal. So we're wondering if these all 3 are equal. And if they are, then the side lengths are proportional and we have a similar shape. So I have to simplify these to check it out. So 6/8 simplifies down to 3/4. So that one's also 3/4. And then that middle one, we can divide those by 4. 8 by 4 is 2, and 12 by 4 is 3. So these are not equal. So they are not similar shapes. So we test the ratios of the lengths of the corresponding sides to see if we have equal ratios. Since they're not, then it's not similar. Now, on to our next skill. We're going to be determining, this is the key right here. Put a little star here. Put a little star right here. We're going to be finding missing measures. Now, what do we need to do that? We need to, a lot of times, find a scale factor. We've talked about that. We've talked about how we can divide the new by the old and get our scale factor. Now, when we divide, that is a ratio. And that's how this section explains it. They explain the scale factor as the ratio of the lengths of two corresponding sides. So the fraction of the two corresponding sides. So we've learned it as new divided by old, but you can think of it as the ratio of the two corresponding sides. Anyway, we can use that scale factor to find the missing pieces of the puzzle. First, though, they want us to do this A part. Oh, wait, actually back up. First, you have to realize that in this problem, they're telling us that they're similar already. They're telling us these shapes are similar. So we know the corresponding angles are congruent and the corresponding side lengths are proportional. We know those two things from our key concept from the previous page. So what are we going to do? We're going to use those key concepts to help us find missing measures in part B. But first, we have to describe transformations that map one onto the other. Well, anytime you have similar shapes, you need a specific type of transformation. You need dilation. Anytime you have different size shapes, you're going to say, oh, we need a dilation. And then typically you need a dilation and then you need to slide it over. So you need a translation. So that's what this guy is. And that's how you would map the two onto each other. All right, that's not the big idea here. The big focus is finding missing measures. Let's go back up to the shape here. And let's realize, aha, we have a missing measure over here on the second shape. A key thing to realize is, what does that correspond with? What side does this correspond with? Just visually, it looks like it corresponds with this side here. All right, so we need to kind of use that number 12 to help us find what M is. But first, let's look over the different methods for doing this. All right, method number 1 is to find the scale factor. All right, so we're going to find the scale factor. How do you find the scale factor? Well, we talked about it being new divided by old, but also finding the scale factor, you can just do the ratio of the side lengths. So right here, we find the scale factor by finding the ratio of the side lengths. So you can just, how they get the 15 and the 10? All they did was they just picked two that were there, two that had numbers for them. We already know they're similar, so we know that they're all going to be proportional. And it's all going to work out perfectly when we find the scale factor. But we find these two, and we use that ratio here as our scale factor. And what's a scale factor? It's what we multiply the length by. So then what happens? Once you find the scale factor, you can just multiply that 12. Remember, we said the 12 goes with the M up here. You multiply that 12 by the scale factor. All right, and I'll show you with some lines here. Well, what they did is they said, well, what would multiply by 10 to get 15? Excuse me. What would multiply by 10 to get 15? Well, you'd multiply 3 over 2 by 10. So if I multiply that by 3 over 2 to get 15, then I'd have to multiply this by 3 over 2 to get my answer. And what's the answer they get? They get 18. All right, so you just have to find the scale factor between the two shapes and use that to find the missing piece. The other way to do it, and I think this is more consistently right, people use this in my years of teaching, people use this a little bit more accurately. All right, but you do have to know how to solve proportions. All we have to do is set up a proportion, outline this. Set up a proportion. So we're going to, one of the pieces has to be the pair that includes the missing side length, right? This is one of the pair that includes missing length, right? And the other one, this one over here, can be any other pair. Now they have to correspond. So you can pick any other pair. They just happen to choose the same ones from the one above. They chose these corresponding sides here and here and made that ratio. All right, well, how do we solve this? Underline cross products. We multiply the m times the 10 and the 12 times the 15. All right, then we have this equation, and we just divide to isolate the variable like we've done a million times, and we get that number 18. So you have to choose which way you like to do it, and you get to practice one right now. All right, all I want you to do is to try this one. Oops. To try this one right here. And you can do the method of your choosing. All right, but you're finding the length of WZ. So what's WZ? Ah, it's right here. All right, pause and try. All right, we're back. Now I am going to find which number WZ corresponds with, and I think it corresponds with AD here, which is 13. Now, all I need is another pair of corresponding sides, and I see right here corresponds with that. So I'm going to use that as my base here, and I'm going to go. I'm going to put a variable here for WZ. Let's put an X there. All right. What do? I make a ratio of corresponding sides. So X goes with 13. And the other pair that I'm going to use for my proportion is 15 over 10. Now, you could have also done something like this. You could have also said 13 over x equals, what would have to happen? If I flip one, I got to flip the other. All right? The top numbers have to be from the same shape. So see, they're from the same shape there. And the bottom numbers have to be from the same shape. And you can see that they're both from there. All right? So all right. Trying to erase, but it's not working for me. That's okay. Now we have to cross multiply and solve, and that should give us the correct answer. Come on. Yay. Almost there. Erase, erase. Erase, come on. Come on. That's annoying. All right. We cross multiply. So we get 10x equals, what's 15 times 13? 15 times 13 would be, let's see, 195. And then we're going to divide by 10, divide by 10. That gives us x equals 19.5. So we get 19.5. Now we want to see if this is reasonable. I'm going to put 19.5 here. Let's see. Seems reasonable. Seems reasonable because it looks, I'm just looking at the numbers, 10 to 15, 13 to 19.5. Yeah, that looks reasonable. We'll say a little bit more. About half again, as we say. All right, and let's check it to make sure. Yep, 19.5 is the answer. All right, I did not show you the scale factor way, but you could also do it that way. I will demonstrate really quickly. If we want to get this missing piece here, we need something that will multiply. We're wondering what will multiply by 13 to get to that number. So we have to wonder, well, okay, well, what multiplies by this? All right, 10 times what? 10 times what equals 15? To find that scale factor, we're just going to do, all right, 10 times what? So we can just do divide by 10, this right here. 10 or 15 divided by 10. So the scale factor would be 1.5. How do we use that scale factor? We say, oh, well, 13 times 1.5. 13 times 1.5, and 13 times 1.5 is that 19.5 that we got earlier. All right, if the scale factor way works for you, awesome, use it. If not, use the proportions. That's it. That's all we got. Beautiful day for math. Woodworth out.